Hi, everyone. My name is Fabiana Clemente, and I'm co-founder and chief data officer at YData. And before we get started, I just want to share a few words about myself and my background. I have specialized myself in applied mathematics, and later on, I have dedicated my career to data science and machine learning. I have also taken a master's degree in the area. And well, numbers have always been my passion, which of course made data science the perfect fit as a professional career. And as in any data scientist, I've also tasted the bittersweetness of AI development. The data is not always available, either because of collection is not that great, or because privacy constraints just makes the process of accessing the data pretty hard. And well, as many of you know, things just don't get easier when you have the data finally on your side. And truth to be told, foundational models are also no exception to these struggles. Even when we see models such as LLMs being used on a daily basis, the true struggle for a perfect development of those models is getting the access to the right data. And well, this brings me to the topic that I'll be covering today: synthetic data, a generative AI for enhanced data quality in the era of foundational models. I have already shared a few words about me, but well, I have tons of interest in the area of data science, but those include more specifically time series and generative models. So I've been using generative models for quite some time, and I'm more than happy to today share with you all my knowledge and experience around those models and how they can be used to generate synthetic data that is actually relevant for the development of machine learning models and other business applications. Well, um, to get started, let's think about how foundational models have just changed the landscape of AI in the last year. Truth to be told, they are everywhere. So from DALI to ChatGPT, we all went nuts. They are amazing. They have delivered amazing capabilities. So in a nutshell, these models are trained on broad data sets of usually unlabeled data, which makes them very special. They are indeed, and no one can deny that, they are the future of AI, where AI models are not only reusable, but also flexible, making them applicable to just about any domain or even different industry tasks. But even though these large models can cost a lot just to train, each and new generation has produced and increased their accuracy and their flexibility, which is enticing for the imagination of the whole industry with the new potential and applications. These models are usually trained, as I mentioned, in the large amounts of data, and they have shown to be quite handy and, well, quite accurate sometimes. But the truth is, the better the data that you have access to, the more you have an unfair advantage. LLMs in particular have marked a significant leap in our perception of AI capabilities. LLMs like ChatGPT by OpenAI have taken the market by storm and redefined the landscape from several areas, from healthcare to marketing to even cybersecurity. LLMs are models with incredible capabilities, being able to process and understand context, generate coherent text, and even perform some tasks beyond language, such as code generation, right? All of these capabilities are only leading to a fast resurface of the AI landscape, not only in terms of trends, but also in what concerns the commercial landscape, right? New products, new capabilities. We are seeing serious competition in the area of code generation, right? With GitHub Copilot and even Amazon Code Whisperer. But what about the data that is used to train these models? And what data will feed and keep helping the evolution of these models? Well, have the LLMs finally solved the biggest bottleneck of AI development so far? Is it true or safe to say that no more garbage in, no more garbage out, so it's completely over? well, not quite, right? So, although foundational models and models like LLMs are conceptually less sensitive to the variability or the quality of the data, the truth is that they not always work out of the box. In addition, these models are considered, well, so far, generalists. So, of course, there are variations and there are other possibilities. There are some developments in the area to make them less generalist and more specialized. But in a nutshell, foundational models still have prevalent issues, such as they're not reliable yet, not as a whole. Typographic tests have shown that foundational models can be easily tricked. They are not context aware in some cases. The lack of common sense ended up in the production of non ethical results from time to time. And, well, this is an oldie, but a goldie for sure. Bias, yes, bias is still a problem. The results are sometimes discriminatory and stereotyping. Furthermore, the success rate for AI adoption is just getting smaller. Truth to be told, the more complex the models, the harder it is the adoption of AI. And well, what can I say? In order to adopt successfully this type of models or any model in general, there is something that I really like to emphasize. Data should be treated as a product itself. Thinking data as a product, it means that data should be it means to put the business needs at the heart of our data flows and preparation design. So this means that business will definitely influence how we access, collect, prepare, and transform our data. And that brings me to one other question that you might be asking yourself. So, what does it mean to have or to treat data as a product? What are the characteristics that we should take into consideration for our data? Well, this can be called or by many considered data quality. And interesting enough, data quality have several dimensions. It can be described uh, by because data needs to be accurate. It might mean that we need granularity, variability, variety, and all of this are really important to ensure the generalization and robustness of our insights, but also the models that we develop. And these have been proven even for LLMs. For example, the Chinchilla paper definitely stated that it is possible to train smaller models if you really use a well curated and accurate data. But, well, what is good data? 70 dimensions. There are papers stating that. So, uh, actually, data quality will definitely depend on the business, on the use case, and on the type of model that you are using. And, well, dimensions such as accuracy, completeness, consistency, variety, and validity, and representativity will be mainly important for many different models. And because today the topic of focus is synthetic data, I will be for sure doubling down on the characteristics that we all understand that are important for the generalization: variety, representativity, and completeness. Those are definitely elements that synthetic data can help us out with. And, well, let me show you how synthetic data generation can actually be a very valuable strategy when real world data is either not representative, limited, or even in many cases unavailable. And well, after I have mentioned synthetic data so many times, one of the questions that you might be asking yourselves is, what is synthetic data in the end? Synthetic data can be considered as any artificial generated data that is not collected from real world events. It keeps the same characteristics as the real data and is not traceable back to real individuals or real processes or real events. As stated by Gartner in their latest report, synthetic data is for sure the next big thing and what concerns AI initiatives to a new and taking it to a new level. The use of synthetic data will probably open several doors. For example, that enable data democratization, mitigate the presence of bias, and, well, when combined with real data, can really enhance AI performance. But How can one generate synthetic data? Well, not all synthetic data holds the same value, and many of you have probably at some point bumped into a concept of synthetic data. Different types of synthetic data delivers different values and can be used in different ways and for different use cases. And for example, one that many of us have probably seen just because it's used for quality assurance tests or even to stress test systems is dummy data. And dummy data, although it sounds very simplistic, is also very important still. We can see dummy data as being a programmatic generation of data that holds no real value. So we cannot use this data for running a machine learning model, for example, or to derive insights from the real world. But we definitely can use it to test structure, to test business rules, and to test logic. On the other hand, data-driven synthetic data is considered to be a more uh, rich and realistic type of data sets that are actually not only able to replicate the structure of the data, meaning the same type of formats, the same distributions, even the same type of sequences, but it can also hold value. So whenever you build or decide to build a data-driven process, such as a machine learning model, out of the synthetic data, you can actually get real value from it. And this is great, especially when, for example, the access to data is really limited and you want to have a privacy preserving manner to access data, or just when you want to augment your data sets. Many of you have probably dealt with situations where you don't have enough examples or a certain behavior, and you just want to have more with a certain variability. That's where data-driven synthetic data can really help you out. Last but not the least, simulated synthetic data. This is a totally new level of synthetic data and brings also different benefits and have a totally different role. Uh, in this case, we can take some real world data behavior or real data assumptions. So let's say population behavior, knowledge that we have from a business context, and we can extrapolate new scenarios based on our past learnings. So this means that I'm no longer bounded to what actually happened, but I can create new scenarios and new realms where I can test hypotheses. This is highly useful, for example, to risk assessment or risk management when where we want to tweak different scenarios, for example, or whenever you simply know that a certain behavior exists. It's simply that it's not that easy to make the collection of those events. And well, that's when simulated data can really help you out. And well, if we think about images, this different types of data are very obvious. So for example, a very common way to generate synthetic data images, many of us have used just a cropping or adding elements with different environments in the background. This is a way of building your synthetic data. You know those behaviors might happen, you just didn't collect them, so you generate them. For text, there are also different routes, right? If we think about that type of data, we can use, for example, synonyms in order to make our corpus richer and to replace some words. We can also use strategies such as back translation that usually generate high quality synthetic data. But last and not the least, and probably one of the most exciting latest in research, is the use of generative models, more specifically, the ones I'm going to show afterwards, like, for example, LLMs. Well, but before deep diving into the different types, I just want to show you that there are different and many different generative models. All of them have different characteristics and different capability. Today, I'll be focusing a bit more on the deep generative ones, but all generative models in general aim at learning the true data distribution of a specific data set. Um, so and they can either be implicit or explicit. The two most commonly used approaches, and probably that you have heard at some point, is variational autoencoders and generative adversarial networks, which I'm really a fan of. But we also can see other models that are a bit more simpler, or let's say um, we have heard of them for decades now, like Markov chains, and they are actually widely used in industry with quite good results. So let's just very quickly go through the different ones and different models and all different capabilities in terms of the synthetic data that they generate, but also they have different pros and cons. Just to give you an example, all of these models can be used either for tabular or even for text data, and Bayesian networks specifically, they 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 are great. So but they are stable, but they are far more suitable for smaller and, for example, noisy data sets. They are great at handling complexity and dimensionality of data from verticals such as healthcare, where you have several different columns. You also have nevertheless, they have some cons. So they are highly impacted by the order of your data or even the type of sequences that you have in your text, which makes them very hard to succeed with no prior knowledge on the business or on how the data behaves actually. And well, they have quite a hard time as well at scaling for larger volumes of data. And what concerns scans, they are pretty powerful at mimicking the behavior. They are pretty powerful. In reality, they mimic the behavior of two networks, right? So they have this min max game kind of knowledge logic where you have two networks actually competing until one can trick the other. They are very powerful for the generation of synthetic data. So in terms of pros, they can easily scale with the volume of data. They can really well adapt to different types of data. So this is the type of model that you can actually use for text, images, and of course tabular data. They need to be adapted in terms of architecture, but they are quite accommodating. They also tend to introduce uh, a lot of variability to your synthetic data, which is great, not only for privacy compliance use cases, but also use cases where you are looking into have models that are able to generalize more. On the other hand, they have some cons, of course. They are hard or very hard to optimize and fine tune. They're actually one of the hardest type of architectures to have optimized. And they very commonly suffer for mode collapse, not model collapse. I'll be touching upon that later on, but definitely mode collapse. So they tend to learn a specific distribution of your data or behavior of your data and generate a lot of that. So they are kind of tricky, though for big, huge data sets, they are really great. And last but not the least, I wanted also to touch upon transformers. So um, NLP has enormous potential to advance in many aspects for different industries. And in this case, they facilitated a lot on the analysis of unstructured data. Uh, in transformers itself, they bring a lot of benefits. So they do not, different from GANs, they do not suffer from mode collapse. They are very scalable for and really helpful for synthetic data generation. They can easily scale with a lot of volume of data and can be very easily adapted as well for different types of data. Nevertheless, they are data savvy, so they are not that suitable to synthesize smaller sets of data, and they might actually have a hard time understanding sometimes business constraints. Of course, there are ways to overcome that, and we can see that in a lot of models coming out today. But well, we are transformers are very well known. And we are very well aware of their capabilities, as the transformer architecture is actually the fundamental building block of all LLMs that we know. And well, that's exciting, especially when we see a lot of need for synthetic data generation, and there is a lot of discussions around the use of synthetic data to keep evolving LLMs and the use of LLMs for different verticals. And well, so I think you are already captured why synthetic data can be so important in the era of foundational models. It is not only a cost and speed and efficient way for data acquisition, it can unlock data sharing and access to data, supports responsible AI, so it can be used to the bias or deal with bias mitigation. It can enhance machine learning performance. It can be also a very faster and product testing and development way. So if you get access to your data sooner, you will also be able to test your products way faster. But, and well, this is even more important when we see the impact that LLMs are having in the development of AI products. So traditionally, we saw this flow where um, data was acquired first, and we had the model to be built, and that model would be integrated into a product. Actually, with these foundational models, we see a total difference in the flow. So we start with the product, then if the product is successful while using our baseline model or an out-of-the-box model, we train it with more data, and well, we want to scale that model for other use cases and other examples. So we feed it with more data and more use cases of that data. So having this mindset changed, it means as well that the focus of the development for AI engineers will be more and more around data. And well, as we have mentioned, data is actually one of the hardest thing that you can collect, is one of the hardest thing to have access to. It's so scarce. And we see different companies even closing their access to their data sources like Reddit. So the more data you have, the more successful you will be building new AI products in this new landscape. And that's why synthetic data can really be a game changer for your product development workflow. And well, and I think that summarizes a bit what I've mentioned. So why go synthetic when you want to train foundational models like LLMs? So there are tons of reasons, but I would say one of the most important would be around liability and legal issues. So you want to have the access to the data, you want to be able to train with specific data, but if that data is real and you have privacy concerns, you cannot use it to train this model. So synthetic data is actually a very friendly way to do so. You can control biases. After all, not all the behaviors you are able to collect them from the real world data. You can fill in the gaps, or you can even do missing data imputation with synthetic data. And again, synthetic data is just a very easy way to get access to the data that is so hard to collect from time to time. But, and as many of us have seen, synthetic data or the use of synthetic data can lead to data contamination. And that's one of the biggest topics around the use of synthetic data for LLMs. But that can be totally avoided. And how? Just by making a very specific question to yourselves, which is, how good is my synthetic data? As with real data, we need to have a trustworthy process to validate the quality of our real data. The same goes into synthetic data. It's very important that you always understand the quality of the data that you are using and where you are using in combination with which models. For that, I would say that, of course, this depends on the use case. There are three main dimensions where synthetic data can be measured on in terms of quality, being fidelity, that answers the question on how similar is the synthetic data as compared to the original data or the real world behavior. In terms of utility, how useful is my synthetic data for the downstream application? So in reality, does this answer the needs for the business or for the use case that I'm testing? And last but not the least, does my synthetic data contain any information that can represent a leakage from the original data or real world information? And well, all this process should be taken, all this process of synthetic data generation, and in order to avoid any overfit, should always follow the best practices of machine learning, which is use always and all out. We want to ensure that you are not overfitting to what was seen in order to avoid contamination. So although this is a bold claim, and I promise I have a point here, the realism of data is many times overrated. So synthetic data is definitely should be used with cautious and with the right process, but can actually be a very cost efficient and can change the way we build AI models. So definitely it's a way to go if we want to overcome or surpass the challenges of data collection. I hope you have enjoyed. This is a very quick recap on synthetic data, but I think we can open for questions. Okay, I think there are a few questions. What's the role of causality play in generating synthetic data? Um, Definitely, causality is a very important plays a very important role in the way we understand the data. And in terms of the synthetic data generation, it is important if we want to replicate the real world behavior. So it depending on the model that you choose, there are some causality methods that are actually used for the synthetic data generation process, or for example, Bayesian networks are usually used on the context of analyzing causality, and they are actually very great as well to in the generation of synthetic data, for example. Um, the other question that we do have here is whether there is a big difference between data-driven versus simulated data. Um, there is, in a sense that if we consider that the data-driven is assuming that you have a training data set, you can learn the distributions from um, uh, that data set. So you learn the distributions from the existing data. Whereas with simulated data, you don't have real data to understand or derive the distributions from. So actually, you either use assumptions or you either use, when I say assumptions, it can be the assumption of the distribution would look like a certain way, or the assumption that you have a function that will model the behavior. Okay, so it does it does have that difference. So it's more the baseline or the foundation that is used to generate the data. It's very different. One is totally learned, the other one is more based on assumptions. How do we ensure, that is the next question, which is how do you ensure that the model that was trained on synthetic data is performant when tested in real life? How do we minimize the performance gaps between synthetic data and real data? So this is actually a very long answer in the sense that there are several layers to answer this question, but I'll keep it short in the sense that you can use several metrics, and you should always use several metrics and have a very well defined process of to validate the quality of your synthetic data. In terms of utility, which usually stands for the performance of training a model, for example, on synthetic data and test it in real life, there are actually several metrics, but one of the most efficient is the trained synthetic test reel. So that's usually always applied by the end of the process. For example, if you have very well defined quality process in your system, that what is done is that you train on your synthetic data, and then you validate the quality of your model on the holdout of real data. Why the holdout? You want to keep your real data, some part of your real data unseen, so you can really assess whether the model, uh, whether the synthetic data produces a model that is actually not only generalizable but also performant. So that's one of the ways. But of course, there are more metrics that you can apply though this one is the more obvious. The other one would be um, to do feature importance analysis, for example, that also gives you a very good idea of what was the information that was lost. In terms of the minimize the performance gaps, it does depend on how much you want to generalize and how much you want to avoid overfitting. For example, if you are just replicating outlier behavior on your synthetic data, you are actually overfitting. Um, do you want that? You don't want that. So that those are capabilities that we can tweak, and those are characteristics that you can take. And also around variability, how much do you want to generate outside the known distribution or the known cases? Do you want to add more variability? All of that kind of play a role in your decision on how you want to minimize the performance gaps between the synthetic data and the real one. I'll take one last question, which is how generative AI can be used to generate synthetic data that meets the data quality criteria. So there are several models. All of those that I've mentioned today can actually be used to generate synthetic data that meet data quality criteria. Nevertheless, there are things that do impact the choice of the model. So one of them is the size of your data. The other one will be around the types of behavior of your data. So for example, when dealing with text, do you want to generate simple tweets? Are you generating, for example, very large corpus? Does your corpus have a lot of variability? So depending on that, that means that you will need different type of models or architectures to be able to generate data that has this quality criteria for you. So I would say that it a good selection of model and tuning of the parameters does play a huge role, and usually the choice of the model is highly dependent on the data itself. Just to wrap it up, what libraries, if any, are out there to generate synthetic data? So there are many. It depends on the type of data that you are dealing with. I can tell you that we have open source for that. So if you access YData Synthetic, it's our open source for synthetic data generation. We also have an optimal version of synthetic data generation, so you don't have to deal with the hyperparameter tuning. And that option is offered in our flagship product. We have a community version, so it's free for usage. You can freely test synthetic data generation if you are curious to see it. But of course, there are other open sources available depending on the type of data. There are a few models for images, but usually it you should look into, for example, the architectures. So if you see a model architecture, for example, a variation autoencoder, or again, or even a transformer, you can search for some research on that area and you'll find it in open repositories for you to test it out. Or for example, if you are using text, you definitely can look into models such as Llama to play around with synthetic data generation. I highly recommend it if you are into that. So, well, I hope you have enjoyed and happy to connect with you on LinkedIn. Look into or search for me as Fabiana Clemente, and I'll be more than happy to address more questions that you have. And feel free to add me.